All right, let's go tackle a tricky one. This is for finding the equation of tangent lines with a point not on the curve. This makes it this can be a little bit challenging, so follow along. Got a little example problem, and we're going to describe what's happening before we start solving anything. So let's find the points on the curve. Points, multiple, not just one. On the curve y equals 1 minus x squared. Where tangent lines, where the tangent line passes through the point 2, 0. All right. So we got a curve. It's a parabola facing upside down with a y-intercept of 1. You can tell because there's a positive 1 in the 1 minus x squared, and that's a negative x squared. Means it's a parabola facing down. The point 2, 0 is not on the curve. Let's see a picture. Now I drew this, and my sketches are dog shit for the most part. So I got a little something. Oops. Talk about that stuff on the right later. Okay, so there's our point. We got our point right down here, 2, 0, and we got our curve facing down. Now, sorry about my graph. To actually show this thing, I have to kind of draw it a little bit wrong and not to scale. My excuse. I don't graph well, but I label stuff, so it's not exact. We're getting the point across. Now we're going to take that point 2, 0, and there's going to be, I'll just tell you right now, there's 2 different points on that curve where 2, 0 is included on the tangent line. So just for example, let's kind of zoom in a little bit. And go into here and let me get this little ruler out and go. I don't know. Maybe it goes like this. Somewhere in here, we're gonna have. Whoa, a little crazy down there at the end. Got some sort of line that goes through there, so this must be some point right here. You know what I mean? Some sort of point right there, where the slope of the tangent line is also going to be equal to the, or it's also going to go through the point 2, 0. And we just have to find the equation of that line. Now, there's also going to be another one down here somewhere. I don't know. Maybe it's like, zoom out. I had to draw it wrong to make it actually be like to scale. So there'll be another one that's down here. Or this thing would like kiss off. We just kept going. Oops. So there's some sort of point down here. I don't know. Maybe it's there. Maybe it's there. Whatever. But can you tell? There's 2 different spots where the equation of the tangent line might go through that point. They do go through that point. So our job is to go and find it. Now let's not worry about the one down below. Let's just face everything. Let's just look everything up at the top here. So get rid of that. Put it down back in. Gosh, I suck. Right there, it's 2, 0. Okay. Okay. We want to go find whatever these points are right here. I'm going to call it A, B. A, B. Or x1, y1. When you see that with the subscripts underneath, like x1, y1, that means it's a particular point. Like A and B are fixed numbers. So let's look at our equation of a tangent line. The equation of the tangent line, we get y minus y1 is equal to the slope of the tangent line times x minus x1. But what we're really looking for here is we're looking for x1, y1. That's what we're looking for. We can find the slope of the tangent line. We can find the slope of the tangent line right now. Because we know that it goes through the point 2, 0. We could just plug in x equals 2 into the derivative of y. We can get that right now. That's not what's making it hard. It's getting the x1, y1. That's the game. We're trying to find the points. Those are the particular points. Now maybe we want to just write it a little bit differently, where we just say y minus is equal to the slope of that tangent line times x minus, and let's call it, hey, how I called it a, b down there. A goes with your x, so x minus a, and y minus b. All right, dope, 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 dope. Cool. Let's go get it. Let's go get it. Now that we have this set up, we're trying to find A and B. Let's go get that slope of the tangent line. Let's go get the slope of the tangent. So we come back up here. We're like, all right. Let's just go take our y. Our y is equal to 1 minus x squared. And let's go get y prime. And we call this negative 2x. Cool. So that's the slope of the tangent line for any given value of x. For any given value of x. But I don't want to put in a particular value of x. I can put that 2 in there and we can make it work. But I actually want to go a little different. I want to let that value that we're going to plug in, I want to let that thing vary a little bit. So why don't we do this? Since we want it to go through this point here, let's not plug in 2. We could plug in 2 and find out we get a little negative 4 there, everything freaking honky-dory. But why don't we plug in A instead? That A, that other x value. So we do that, and we're like, okay, well, y prime is equal to negative 2 times that A. And that's some particular number, so we can call that the slope of the tangent line. Negative 2A. We keep cleaning. We're like, all right, y minus, all right, we got some sort of b going on here. And that's equal to our new slope of the tangent line. Let's call that, I'm just going to put that in purple. Negative 2a. Actually, screw that. I like that. I want it in green. I want it in green, sorry. So negative 2a, because I want you to be able to see the a's. And that times x minus a. All right. Cool. What's A and B? It doesn't seem like we're getting anywhere, but we are. Now we finally made it. We're to the point. Now we're finally going to use this. The 2, 0. Because we know that when you have an equation of a line, you can plug your x and your y value into it and it's always going to be true. That's the point of the frickin' equation. That you can solve for x's and y's, just pop an x in there, it's going to tell you exactly what y is. But we already know what x and y are. We're just going to plug it in. We know it's going to work. So we take it, well, now we're going to pop in for our y value, we put in 0. And for our x value, we're going to put in 2. So let's go down to here. I have a heart attack right now. I thought my computer was going to freeze on me. I would have screamed and cried. There's our minus b. Oops, I have right in x. We don't want x. So our x value was 2. Our y value is 0, because we're from the point 2, 0, right? We know that that's there. So let's just do a quick little solve. Let's see what's going on. So now just algebra. We got negative b is equal to negative 2a times 2 minus a. Multiply both sides by negative 1, just so we don't have to deal with negatives. And then we'll bring it in. B is equal to 4a minus, what's that, 2a squared? Okay, well shoot. What's that do for us? What does that do for us? Let's see. Oh, wait. B. There's something we haven't used yet. If our y value is b, what is this formula? If it's true, what do I plug in right here to make that true? It's the a value, right? From our original equation, we can take this and substitute in for b. Now everything is in terms of, that's the 1 minus a squared from up above, is in terms of a. Now let's go solve for a. We got rid of all the b's. You still following along? Here comes the algebra. So let's move 2a squared over and the 4a over. And we'll put it in descending order. So that's the a squared minus 4a plus 1 is equal to 0. because that's what we want to set stuff up. We like setting things equal to 0. That's how we're going to solve for this a. And we're going to get two values. Now this is going to be the x values. It's saying that you're going to get two different x values. Two different x values. They're going to make this true. Yeah, we already know that. You're like, no shit, we're going to get two different x values. There's going to be two different a values. Shit, there's going to be two different b values. So we're going to go and solve this. Now, some of y'all might like the quadratic formula. Go for it. Use it. It's valid. Because this doesn't factor. I like completing the square. That's just my style. So I go a squared minus 4a. So I look at this 4 and go, all right, or negative 4, and I go, all right, what's half of negative 4? Negative 2. Square it. What's negative 2 all squared? 4. So I'm going to give it a 4 and take it away. Just right in this gap, right there. I just put plus 4, minus 4. Completing the square. It's simple. Once you know how to do it, once you get it down, you stop avoiding it. You freaking shortcut stuff. Go cut something in half and square, then add it, and then take it away. Come on, it's not that bad. So this creates a perfect square. That's a minus 2 all squared, and then minus 4 plus 1. That's negative 3. Shoot, now we just add it on over to solve. A minus 2 squared is equal to 3. Hit it with a square root on both sides, and don't you dare forget the fact that when you hit something with a square root, better hit that number with a plus or a minus. Getting those two different values. Now we can add that 2 over, and we find out a is equal to 2 plus or minus the square root of 3. Now this is going to be two different numbers. 2 plus root 3 is about 3.73. 2 minus root 3, it's about 0.267. Sorry, 0.27. It's about. So we just found our a value. We got those two, so we got the a is equal to 2 plus or minus root 3. So this would be 2 minus root 3 is our a value. About 0.26. About 0.26. And then you would plug it into your original formula and say, well, b is equal to 1 minus, and then this stuff squared. I'm just using the formula from up here. 2 plus root 3 and solve, and then you find your b is equal to 1 minus root 3 squared and solve. And you're going to get some big gross frickin' number. I'm not going to solve the rest of it. I already have my degree. So I don't want to do that. So what your points would be unsimplified and all the way through is, right, it is 2 plus root 3. Now you get to do all that simplification over here. I'm cheating. I'm just cheating. Now the x value or the a value is already good to go. It's just those y values, or oops, I'm sorry, the b values that you would need to simplify. So there would be. There's the two numbers. You simplify it out. I think the one in your homework is about 1,000 times freaking easier. So sorry for this long, drawn out one, but this is how you find the equation of the tangent lines. Oh, you still need to plug it in. Oh, no, just ask for the points. Never mind, we're good. So hope it was somewhat helpful. All right.